Assalamu alaikum. One more scenario for the estimation of the sample size and one more equation to estimate the required sample size for a controlled study for dichotomous data. We'll be dealing with dichotomous outcome like alive dead, success failure, positive for a certain test or negative. We'll be using the same equation that we have used for the continuous data in the controlled study. The only difference would be in the calculation of the effect size, because there will be a different formula to calculate the effect size for the dichotomous outcome. Like if we are measuring, for example, ratios or percentages, not continuous data. We'll be looking into incidence, prevalence, same equation, but a different effect size. So first, we need to set up these parameters before we start the study in order to estimate the appropriate sample size. By far, most clinical trials and studies now use their two-tailed model, unless you have very good reasons to take a one-tailed model. The level of significance, which is again by far 95%, that is to say the p-value is equal to or less than 5%, and the z-score for this is 1.96. The study power, which is again how much you can tolerate a type 2 error, and for this the z-score is usually 0.84 for the 80% power and 1.282 for the 90% power, and these two are the most commonly used powers in clinical trials. The last thing is how much you would expect the effect size to be. That would depend on the difference between the two groups, the standardized difference between the two groups, that is to say the difference in terms of standard deviation. And for this you can do one of the following. The common ways of guessing how much the effect size could be before starting the study is either going through the literature and reviewing any prior research and get a rough idea about how much of an effect size between the two groups could be. You could also depend on your personal assessment of what difference is important in terms of length of stay in a hospital or amount of bleeding or rate of complication. Could it be 10% difference, 20, 30, or whatever? The third thing is to use a special convention like Cohen's d, and he classified the effect sizes into small with 0.2 effect size, medium with 0.3 effect size, and large effect more than 0.5 effect size. One other way to estimate the expected effect size is to use this special formula for the dichotomous data, which is based on the expected proportions of the two groups, the study group and the control group, and the average proportion between the two groups. So to give you an example, if we have two groups here for a certain success rates for a certain operation, in group 1 the success rate was 80%, the proportion is 0.8. Then group 2 success rate was 90%, the proportion is 0.9. The average success rate on proportion is 0.85, assuming that the two groups were equal in number. So the effect size here would be to subtract the smaller from the bigger value because of these two bars here. So that's 0.9 minus 0.8 divided by the square root of the average proportion, 0.85 multiplied by 0.15. So that will give you the number of 0.28 as the effect size. We plug this in here, and then this will be the z-score corresponding to the chosen level of significance for a two-tailed test, and this will be the z-score corresponding to the level of the power. For 80% power, this will be 0.84, and the level of significance, that score will be 1.96 divided by the calculated effect size, which was 0.28, all squared and multiplied by 2. This will give you 200 cases are required for a sample size in each group. The formula for the number required in each group in a controlled study with dichotomous outcome will depend on the z-score for the chosen level of significance, which is usually 95%. The z-score for a two-tailed study at a 95% level of significance, corresponding to a p-value of less than 0.05, would be 1.96, and that's always used in here. The other z-score refers to the z-score of the chosen power, which can either be 0.84 if you have chosen 80% power, or 1.282 if you have chosen 90% power. The effect size can either be estimated from the literature or from a clinical sense or clinical assessment, or from solving this equation, guessing what percentage you would expect for the proportions of the test group and the proportion of the control group. We've been through an equation to estimate the required sample size for a controlled study with at least two groups using dichotomous data. Assalamu alaikum.